Welcome to Miss Maggie Teaches. And today we're going to be talking about, and we have Axel here to help us, we're going to be talking about acceleration. And we've mentioned it before. And so today I just wanted to take a little bit of time to go a little bit more in depth, and then we'll do a practice problem. Oh, sorry. We have Kai here, so she was just pointing out we had a little bit of an issue putting things together today. My paper, it was very angry at us, and it took both of us to tape it up. So, yeah.
I'm cornered, man.
It's trying to come away. So it was very curly. It's angry. Anyway, so we'll try to get through this very quickly before it bounces off today and pops me right in the head. So, a quick review. Acceleration is the rate at which our velocity changes. And remember that velocity, again, is a vector quantity. So it is interested in two things. So we're interested in speed, right? So we have our speed, and our speed can do what, Kai?
Increase.
Decrease. It can increase and decrease. So we have to keep that in mind. So we can have an increase in speed. And we can decrease our speed. And both of those will affect our acceleration. And then the other thing that people sometimes forget about is that we can change, because it's a vector, if we change our position or change our direction. So anytime if we were going east and we start to go around a corner, then you are actually accelerating without changing your speed. So a change in direction. So when we do our equation for acceleration, we have our delta V, so that's our change. And then we have our G. And Axel is sad because Chassie won't play with them. Now make sure that you write this down. This is going to be something that you'll see a lot and that we're going to be using. And because we have our meters per second for velocity over second, so it's our units, our meters per second over seconds, what you are going to see is meters per second squared. And then because we're keeping track of these, over here, and if you have your reference table, circle this one, do something to make it stand out. It's going to be something that you're going to remember, want to be seeing there. This is our reference table here that we're keeping track of the equations that we should know by now. So we have our velocity equation, which is distance over time, and our acceleration, which is a change in velocity over time. And so now we're going to do a practice problem. Oh, I'm going to keep this. Okay, let's hope it doesn't bonk us in the head. You'll see I got about 10 pieces of tape on it.
Up at the bottom.
The bottom's coming up already. Okay. So again, oh yeah, here goes. She's angry already. Whew. Okay. So we're gonna read through it first. So a car changes its velocity from 10 meters per second to 5 meters per second to avoid a deer. What was the car's acceleration? So the first thing we're gonna go through and do every time we do this is we're gonna take our inventory. So we have an initial velocity, right? There's our meters per second. First thing we're gonna do. So initial, that little I there, so our initial velocity is our 10 meters per second. Then it's going to a different velocity. So there's our 5 meters per second. So that's our final. Little f. Okay, so it starts here. It starts at 10. It goes to 5. So what do we know about the car? What's it doing?
Slowing down.
It's slowing down, right? Which is normally what you do when you see a deer. You're not going to want to speed up. That would be a problem. So it's avoiding the deer. Oh, I forgot to put it in here. We can't really do this problem. I skipped a piece. Initially, when I wrote it down, whoops, it's that it does this in 3 seconds. So, in 3 seconds. If you actually got that on a test that I was giving you, that would have been for real. You'd have just gotten it right, because that's my fault. You could do nothing with that information except for tell me the change of velocity. Now we can actually solve it. So, here you go. Here is your 3 seconds. So now you have your t. Okay? Now we can actually do the problem. Oops. Okay. So back here, here's our equation. So acceleration equals delta v over t. Now remember last time I told you that when you take these kind of tests, they like to make you have to do 2 things at once. So it's always, generally speaking, a 2-step problem. So the first thing that we have to do is figure out our delta v. Anytime you have a change, that delta, it's always final minus initial. So it's v final minus v initial. And you can plug it in that way and just do it. But I'm going to do our first step first. So we know our v final, which is 5. Always keep your units in. Minus our initial, which is 10. So 5 meters per second minus 10 meters per second is going to give us
-5.
-5. Again, when we're talking about a vector quantity, we have to remember that this means that we are slowing down. So this is important because this gives us our direction. That we use this to say, okay, this is important. This is giving us our directionality. So now we can go back into and plug this in. So this is our delta v. We have acceleration. Delta v is our -5. Our t, we get back up here from our inventory, which is our 3. And this is again perfect. We have our meters per second over our seconds, which we knew we needed right here from our units. So we've got everything set up that we need. So, on your phone, on your calculator, I'll give you a second. I have my calculator right here. I was going to hand it to Kai. Just got to clear it out. What is it?
1.6.
1.6. I got 1.66666. So I'm gonna
7.
Yeah, so I'm gonna just round it to 1.67 meters per second squared. Remember, we have to keep our negative because that's our directionality. That and this again tells us that we're decelerating. So we're slowing down to avoid that deer, which we knew we were doing up there anyway. So this is very important. Got to keep that. Okay, so I will, again, I'm getting some stuff together so that we will have another site ready to do more practice problems if you're interested. As soon as I have that up there, I'll put the link below this video. And I will make sure that next time I double check to make sure we have all the information that we need in our problems, for our practice problems. And we will be moving on to some new stuff. So we get lots more to go. So there you go for acceleration. Thanks.